Welcome to This Explainer. So have you ever just stopped and looked at a standard world map and wondered, why exactly does it look like this? I mean, we're so used to it, right? Well, today, we're diving into the absolute magic, or rather, the fascinating spatial mathematics that actually lets us fundamentally shift the center of our global maps. We're going to take something that feels literally carved in stone, our static view of the Earth, and show you how a little bit of clever geometry makes the whole thing totally flexible.
Think about it. For centuries, standard maps have been anchored by the London Prime Meridian. It's a historical legacy, a standard set way back during an era of European naval dominance. But who really gets to decide the center of our world maps today? Is it just history, or is it us? That's what we're exploring today, how mathematics gives us the actual power to question and honestly change that long-held standard. We really aren't stuck with just one perspective anymore.
Okay, so here is where we're headed in this explainer. 1. The center of the world. 2. Translating Earth into XYZ. 3. The math of the sphere. 4. Spinning the matrix. And 5. Reshaping our global perspective. Let's get right into it.
Section 1. The center of the world beyond the Prime Meridian. Let's look at why the traditional center of our world maps is really just one of infinite possibilities.
Just look at the stark visual contrast here. You've got the traditional Euro-centric Mercator projection, right? But then compare that to a modern nation-centered world map, like the one centered entirely on South Korea. Notice how the entire landmass distribution just completely shifts? When Europe isn't sitting dead center, the sheer vastness of the Pacific Ocean and the way Asia and the Americas connect, well, it suddenly takes on an entirely new visual weight. And here's the kicker. This isn't just some artistic choice. It is a literal mathematical recalculation.
Section 2. Translating Earth into XYZ. The front, back, up, and down. To get this new perspective, we actually have to translate the Earth into a three-dimensional XYZ coordinate system.
Okay, to really visualize this, imagine you're standing directly inside the molten core of the Earth. I know, a little hot, but stay with me. That core is our origin point, 0, 0, 0. Now, from there, imagine shooting 3 lasers straight out to the surface. Your x-axis shoots straight out to the intersection of the equator and the prime meridian. That gives us the literal front and back of the Earth. Then, your y-axis shoots out horizontally at 90 degrees east, giving us our east and west halves. And finally, the z-axis shoots straight up to the North Pole and straight down through the South Pole, separating the up and down hemispheres. By grounding the x, y, and z axes in actual physical space like this, we're taking abstract geographical coordinates and transforming them into a super precise 3D grid.
Section 3. The math of the sphere. Building the coordinates. Now that our primary axes are set, let's look at the spherical geometry that plots any location on Earth onto this new grid.
So, pinpointing a specific location happens in 2 logical steps. Step 1 is mapping horizontal circular motion. Think about it. If you're just walking along the equator, your overall height doesn't change, right? Your x and y coordinates are just tracking a perfect circle using sine and cosine functions. Simple enough. But because the Earth is a sphere, we need step 2, which factors in latitude height. As you travel north toward the pole, that horizontal slice of the Earth gets narrower and narrower. So factoring in latitude naturally shrinks that horizontal radius we use for our x and y coordinates.
And the math here is just beautifully elegant. The formula z equals r sine phi perfectly captures the physical height of a point above the equatorial plane. So r is the radius of the Earth, and phi is your latitude angle. As that angle of latitude tilts upward, the z value increases, pushing the point higher into the northern hemisphere. And at the exact same time, it actually pulls the horizontal x and y coordinates tighter in toward that center axis. Basically, this trigonometry translates every single point on the globe, every city, every mountain, literally every ship out at sea, into an exact x, y, and z number.
Section 4. Spinning the matrix, the digital steering wheel. We've digitized the planet, we've built the sphere, and now we're going to spin it.
We are talking about a really profound philosophical and technical shift here. The old center relied on an absolute prime meridian, which essentially locked our maps into a completely static, unchanging Euro-centric worldview. But the new center, it uses relative coordinates. It shows us that the center of the map is literally just a mathematical choice. And that unlocks completely fluid, customized, nation-centric maps.
So how do we actually pull this shift off? Well, we use something called a rotation matrix. The basic formula is v prime equals r times v.
The easiest way to understand this is to think of that rotation matrix, the r in the equation, as a kind of digital steering wheel. The v represents the original coordinates of every point on Earth. By multiplying those original spatial coordinates by specific rotation angles, we are literally spinning the entire globe around a new, user-defined center point. The output, that v prime, gives us the brand new coordinates for our customized map. By applying this matrix, you can digitally steer the globe so that any specific location, whether it's Seoul, Tokyo, or honestly even your own hometown, suddenly becomes the exact mathematical center of the whole map. It's wild.
Section 5. Reshaping our global perspective. Logistics and psychology. Because as you'll see, spinning the matrix isn't just an academic exercise.
Let's look at the actual real-world outcomes of this mathematical shift. First off, it fundamentally shifts a nation's psychological center. I mean, when a country sees itself at the dead center of the map, it completely changes its geopolitical self-image from being, on the edge of the world to being a central hub. It's a huge mindset shift. And practically speaking, it recalculates highly accurate flight and sea distances and drastically reinterprets things like Arctic shipping routes. For example, if you use this math to center a map on a massive port city like Busan, it visually clarifies the absolute most efficient logistical paths straight over the North Pole. That's something that is completely distorted on a standard Mercator map. On top of all that, it forces us to reevaluate the relative positions between entire continents, redefining our cultural and geopolitical connections. Countries that look super far apart on the map you had in your high school classroom might actually be close neighbors when you're looking over the pole in a newly centered projection.
So, because the center of the map is no longer some rigid historical mandate, but rather a flexible mathematical calculation, we really have to ask ourselves, how does our chosen perspective shape our actual reality? If mathematics can place literally any nation, any city, or even any person at the center of the world, how does that change the way you see yours? The math gives us the power to spin the globe. How you choose to look at it, well, that's entirely up to you. Thanks so much for joining me for this explainer. I really hope it sparked your curiosity to look at the world from a completely brand new angle.